Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 23 from the specimen paper for the 2025 0580 Cambridge syllabus. This is a paper 4, extended paper, and this question here is about upper bounds, lower bounds, and limits of accuracy. So we're told about this person's Sergey, I guess, walking 7.9 kilometers, correct to the nearest 100 meters. So a few things before we start going through the whole question. That's kilometers and that's meters. It says correct to the nearest 100 meters. So the units are not the same, so you keep that in mind. The walk takes 133 minutes, correct to the nearest minute. Okay, those two are the same unit, that's fine. Calculate the maximum possible average speed of Sergey's walk. Give your answers in kilometers per hour. All right, so we need to give the answer in kilometers per hour. This is given in kilometers, this is given in minutes. So we take note of that as well. That's minutes, that's hours. So we have to do some conversions here eventually. Now, first of all, we know the average speed of a journey is equal to the total distance traveled. The total distance traveled over the total time taken. Okay, so we have 7.9 kilometers and 133 minutes. Now, a lot of students, the mistake they make in a question like this is they would do the calculation first. They would divide the distance by the time. They would maybe convert minutes to hours, and then divide, and then think about upper and lower bounds. You never do the calculation first. You always find the upper and lower bounds of the values before you put them in the calculation. Okay, always find the upper and lower bounds first before you put them in the calculation. So we have a distance of 7.9 kilometers, and this is to the nearest 100 meters. Okay, and we have a time which is 133 minutes, and this is to the nearest minute, so the nearest 1 minute. Okay, so now let's deal with the minutes first because that's easier. So it says the nearest 1 minute. Okay, so what you do when it says the nearest something, what we do is we say, okay, we take that 1 and we divide it by 2. That gives us 0.5. So we're going to add 0.5 to this, and we're going to take away 0.5 from this to give us the upper bound, which is 133.5, and the lower bound, which is 132.5. Okay, so you can think about it like, if you want, as the number line. We have 133, that the thing rounds to. So the lowest it could be before it's rounded is 132.5. The highest it can be before it's rounded is just before 133.5. Okay, so if we think about this, here you can include 132.5. You round 132.5, it becomes 133. But you don't include 133.5, okay, because if you round 133.5, it will become 134. But this is called the upper bound. The upper bound means everything up to and including that value. All right, everything up to but not including that value. Okay, that's what upper bound means in these continuous kind of quantity questions. So it could be anything just below 133.5, 133.49, 133.4999, anything just before 133.5. So you call 133.5 the upper bound. So this is the upper bound, even though what it means, you know, the time, okay, is between 132.5 included, but less than 133.5 not included. We don't put the equal sign there. Okay, so this is the upper bound, okay, meaning everything just below this value, and this is the lower bound. Okay, so we found the upper and lower bound for the time. Now for the distance, it says to the nearest 100 meters. Now when you have something like this where the different units, you always, well, especially because we have to give an answer in kilometers per hour, we're going to give the answers in terms of kilometers, right? So first thing I'm going to do is I'm going to change this to kilometers. So 100 meters divided by 1,000 is 0.1 kilometers. We're going from meters to kilometers. So we're going from smaller to larger. So we divide by 1,000, because there's 1,000 meters in a kilometer. You divide by 1,000, you're going to go back 3 spaces, 1, 2, 3, 0.1 kilometers. And then we do the same to this. So it's the nearest 0.1 kilometer. So we're going to divide by 2. We're going to divide this by 2. So 0.1 divided by 2, and that will give us 0.05. Okay, if you're not sure, well, this is a non-calculate. This is a calculate paper, but still you can understand how to do this. 2 into 0 goes 0. 2 into 1 goes 0, remainder 1. Put a 0 in front of that one, after that one. 2 into 10 goes 5, 0.05. So basically you just add another 0 and then put a 5 there when you divide 0.1 by 2. That's 0.05. So the upper bound will be 7.9 plus 0.05, and the lower bound will be 7.9 minus 0.05. That's going to give you 7.95, and that's going to give you 7.85. So here we have the upper bound and the lower bound of these values, and this is in kilometers. In kilometers, and this is minutes. This is minutes. Okay, so now we're going to say the average speed is equal to the total distance. Now we want to find the maximum possible speed. So now we got a division. Now when you have a division, okay, and you want to find the maximum possible value, then we take the biggest possible numerator and divide it by the smallest possible denominator. The upper bound divided by the lower bound will give you the biggest possible answer. You can think of it like, for example, as if you're going to have a pizza party, right? You can invite people around for pizza to your house. You're going to have, if you have a large amount of pizzas and a small number of people that are shared amongst, so you divide the pizzas amongst the people. If there's a big number of pizzas and a small number of people, then you get the maximum number of slices each. But if you have a smaller number of pizzas and a larger number of people that you're dividing it amongst, then you'll have a small number of slices each. Okay, so the average speed is going to be, the upper bound, which of the distance, which is 7.95, divided by the lower bound of the time, which is 132.5. But I'm going to divide this by 60. Why? Because 132.5 over 60, that will now be in hours. Okay, this is in minutes. Okay, so I'll write it like this, and when I put in my calculator, I'll put my fraction bar, I'll put 7.95 over 132.5 divided by 60. Okay, like as a fraction, and that will give me 18 over 5, which is 3.6 kilometers per hour. Okay, so there we have the answer for question number 23. So you've got to be careful about this type of upper and lower bound when they're different units, and you've got to be careful. The answer must be in kilometers per hour. Change the minutes to hours, and you have to always find the upper and lower bounds first, and then do the calculation. So we got the upper bound, which was this, divided by the lower bound, which was this, but we changed it into hours. Okay, and then we used it. So that's the answer to question number 23. I hope that was clear. Other questions from this paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of upper and lower bounds, you can find in this playlist. That'll be from the questions from the new syllabus. And questions from the old syllabus about upper and lower bounds, you can find in the playlist over here. And all the questions I have answered on arithmetic from the new syllabus, you can find the playlist over there. Thank you for watching, and see you soon.